Hello Matrix and welcome again. Today we are going to be doing my favorite branch of mathematics, which is calculus. Now the reason I like calculus so much is because it has a lot of applications. So when you go and study finance, you'll be using calculus to maximize your profit. If you do engineering, you might use it with your building materials and how to maximize the use of those. Or if you were doing physics, you could use it in your equations of motion. So what is calculus? Well, calculus is the study of the continuous rate of change. Well, what does that mean exactly? So what I want to do is I'm going to take a practical example. So if I take this orange and I throw it up into the air, the orange is changing all the time. And I can analyze that mathematically. So what I want to do is I want to just take one time where I throw it up and down. And so when it leaves my hand, so I've graphed it here, and we take the height as the y-axis, and with time, the x-axis. So with time, we see that it goes up and up and up and up, and then eventually it gets to a point where it starts to come down because gravity is now pulling it back down. When it hits that maximum height, our physicists all know that it is zero for the period where as it hits its maximum height, the velocity is zero, because it has to stop in order to come back down again. That's not so important. What is important is the calculus bit. And so calculus is the study of the change. So this orange is changing all the time, okay? And so when it leaves the hand, at the beginning, it's going quite fast. And so if I was to look at a point at the beginning, and I'll make a point there, we can see that we could actually draw a tangent and we could figure out the slope. Okay, now the slope is important in calculus because our slope tells us the change in y over the change in x. Remember, from our straight line, slope is change in y over change in x, and that's what calculus is. Calculus is your change in one thing over the rate of change of the other thing. In other words, your change in y over change in x. So let's mark that down as something important. Change in y over change in x. And so we could think of calculus as exactly that, because this would be the rate of change, because as your height in this case changes, your time change, well, sorry, time is actually independent. So as your time changes, your height changes. So calculus is the study of this change. In other words, change in y over change in x. Well, we're quite used to change in y over change in x from straight line functions, which is where you find your gradient. So that would be quite simple, right? I'll do it in light blue. You've got your straight line function here, and you know your gradient is your change in y over change in x. Now, with a parabola, of course, you could do a number of different tangents, and you get a number of different slopes, because that orange, the rate of change is changing all the time as gravity is slowing it down. And in this case, speeding it upwards when it's going down. Gravity is actually pushing it downwards even quicker. Okay, so if we look, we could find the tangent at the various points on that graph, and that would tell us the change in y over change in x at a specific point. But that, we don't have time to just keep drawing tangents. That would take forever. So how does calculus help? Well, calculus allows us to calculate an equation for the slope. What do I mean by that? I mean that if we were to call this f of x, in other words, the function is called f of x. If I found the derivative of that function, so that's what derivative means. It means the equation for the slope. And you might, you'll start to encounter this terminology, f dash of x. And this just means derivative of x. Okay, and in calculus, that means the slope at any point. So the f dash of x would tell us the slope at any point. So we wouldn't need to do all these tangents. We could just find the equation for the slope, and then we could know the slope at any point on that graph. So calculus is the study of the rate of change, okay? And the derivative is that rate of change. So in other words, the derivative is the slope, okay? And when you're asked to differentiate, that means find the derivative. So differentiate, find the derivative just means find the slope, okay? So a straight line graph, the slope would just be the same the whole time. It would just be whatever m is. But now when we look at a parabola function, we end up with a slope that changes all the time. And so the derivative would tell you the equation for the slope. All right, so that's the first thing. When you hear differentiate or derivative, it just means find the slope, okay? Because the slope is the rate of change. And we know the calculus is the study of the rate of change. If I'm repeating myself, I apologize, but I think this is important to just get. And then calculus shouldn't be that difficult because you just need to usually find the derivative. And then once you found the derivative, that would then tell you a bunch of other things. So for instance, let's look at this one at the top where the derivative is a straight line. In other words, the slope is a straight line. Well, at that point, we have a maximum because it's the maximum height, okay? And so our maximum and our minimum is where our slope or our derivative is equal to 0. So in other words, our f dash of x is equal to 0 where there's a maximum, okay? Now, if I had a smiley face parabola, we would have the f dash of x equals 0 still at that point. In other words, the derivative is equal to 0 and we would have a minimum. Okay, so I've just put in there optimization. Optimization is not really too much other than just finding the maximum or the minimum. Because when I want to optimize profit, I want to find where I can get the best profit. And so there with optimization, I'd just be finding the maximum profit. If I wanted to keep the costs down, I would want to optimize the costs. I would actually be finding the minimum because I want to minimize the costs. And so optimization is just find the maximum or minimum. So when you hear optimization, don't worry too much. Just think find the minimum, okay, or the maximum. How do I find the minimum or the maximum? I make the derivative equal to 0. So my steps in calculus are usually as follows. Okay, so let's start again with what is calculus? It's the study of the rate of change. How do I find that rate of change? This is the first step. I find my derivative. In other words, I differentiate. Once I've found my derivative and I want to find the maximum or the minimum, I make that derivative equal to 0. And so that's pretty much the steps that you need to know. Find the derivative, make it equal to 0, and therefore you can find your maximum or your minimum. But of course, if it was that easy, then people wouldn't struggle so much with the calculus. So first of all, what we need to do is we need to figure out how do we find our derivative. And so that's what we're going to do in the next lesson. So if this helped you, please like, subscribe, all that good stuff, and you will get notifications on when the next lesson is. And I will see you then, where we will learn how to find the derivative.